Hey there, it's Sunday, October 2nd, and I'm out here at Adams Rickey Park in Cumberland County. We're just outside the 5-mile range of the closest airport, and the helipads nearby belong to the hospitals, and calls previous to this stay indicated they're not in the flight path for this particular area. So we're all hooked up. I've got the GNSS Surveyor Bad Elf unit connected to the iPad, so I have about 10-foot accuracy GPS data right now to run through the iPad for mission planning. This is our Phantom 3 advanced drone with Centera near-infrared sensor attached to it, so we're going to try a little bit of that today. And over here we've got the laptop running Pix4D to import the data that we capture. So I'm going to grab a couple screenshots of the capture software for mission planning, and then get some video of us flying. Today we're going to use the Pix4D capture tool, which allows us to create a mission plan. So we're going to go with this double grid mission, and it should find where we are. I've already set up some parameters of where we wanted to fly today. I'm sitting in the one corner as indicated there. We can see in this map, the aerial photo for Pix4D, that this area has been undeveloped. It's still all torn up from earth-moving machines and things like that. But if we look outside, in fact, looking in the direction, all these fields are completed now, with some construction going on back there. But this particular one that I've got marked out for capture has been up and running as an athletic field for at least 5 months. We were out here last summer with the Geospatial Technology Camp. This is the first day in 4.5 days where we haven't had rain, so got a little bit of blue sky for flying. So in order for Pix4D to work, we need to actually connect to our drone, so I'm going to go ahead and turn us on here. Won't be flying in the car obviously, but we'll set that out there. But now we can see, once I connect the, go back here, go to our UAV home and DJI Go, and aircraft is connected. We'll go to our camera. Okay, it's got a shot of me. Everything's good. We're going to go ahead and take this out into the field. Now that we're connected, we can come back to the Pix4D capture software. There we go. And I'm going to rotate that just a little tiny bit. Okay, I'm going to use that for autopilot in just a moment. One thing we do need to keep in mind is that the controller needs to be switched to F mode, not the P mode that it normally is. P is for when you're controlling it, F is for autopilot. I can switch it back to the other mode whenever I need to, if I need to take control. So we were set up over there. This is the field out in front of us where we're going to fly. The Phantom 3 is on the ground in front of me. And you can see on the map here, maybe, that we've got a mark in the corner. We're just off the area we're going to fly. So I'm going to go ahead and get it started and see how this autopilot goes. So you can see what's going on right now. I don't want to take my eyes off the drone too long, but it's flying this pattern and marking in white every time it takes a photo. Well, I didn't draw a perfect rectangle, a little bit of a polygon going on there, but you can see that we acquired a certain number of images. We had about 29% battery power left. The Centera AgVolt software worked pretty nicely for the field. Tracked it nicely, ran at 200 feet. The auto track showing where I was. Number of features captured is shown there, and I should have something pretty good to work with. Now I'm not exactly sure why I didn't start taking pictures till the point over here in the corner. Where am I? Right there. Whoops, I just moved the screen. But I think because of the way my polygon was, so I'll have to work on that a little bit better next time. Did it enough on the fly. But not a bad job for the first time. Now we'll try the Pix4D capture. I will say that this particular software basically shut down on me the first time. I had to restart it, and then it worked fine. It's a little bit disconcerting flying without seeing the live camera view. I suppose I could have switched back and forth to the DJI Go app, but wasn't really comfortable doing that. So far this appears to be working the same. I can control a lot more with the Pix4D software. Speed, height, overlap, all sorts of things. It's indicating where I am. It's going up to altitude now, and then we should see it proceed along the line, hear the flight path in a second. You can see it on the screen there, still gaining altitude. I have a small readout on the right, gives me battery percentage, altitude and speed. Looks like it's getting to its location now, so we'll keep an eye on it. This particular app is moving along quickly between spots, but coming to a complete stop for every photo, which the Centera drone app did not. That was the AgVault software. I think I'm almost to the end of this particular run, and then I'll make a turn and go. You can see on the map where it is. Almost right above me now, and it should make its right turn here. And there it goes. Well, the Pix4D software definitely behaved differently than the AgVault software. AgVault kept moving the entire time. It's optimized for a lot of rapid collection of near-infrared imagery, which resolution's not so as important as getting accurate spectral readings. This particular software appears to have taken a lot more points, although that part was part of the settings, I'm sure. And it went to its beginning point and end point really quickly and did a very even 4 passes with lots of images, not the same sort of overlap as the Centera AgVault software. But both used about 32% of their battery to do the entire area. I think that the Pix4D software maybe used a bit more, simply because it stopped to take every photo and took more photos. So my best guess estimate from memory now is that the Pix4D capture software used about 33% of its battery to take these particular images, whereas the Centera software, if I can bring it up, it's still there, used just about 30%. A little bit less power simply because it didn't have to keep starting and stopping. But I got roughly the same coverage, so I'm anxious to see what I get. Well, I'm all packed up now, and it's a really good idea to have a heavy-duty case, especially if you're going to travel with these drones. This Nanook case was ordered when I ordered the near-infrared drone from Centera, and it holds everything really nicely. I've got space for 2 additional batteries, so when I travel with 4 batteries, it should give me a good hour and a half, perhaps, of flight time at recharging. The battery packs and propellers, including spare propellers, all the wires, the Bad Elf GPS software, the iPad sits back there, controller, of course, and other power accessories. So really good option. I'm hoping to get a second case for our second Phantom 3 Advanced. It doesn't have the near infrared, but it'll be good for aerial photos, and perhaps even a third for our GPS units, so we can travel and keep everything protected. So I'm going to head back to the home office now and open up the laptop and take a look at the images. Okay, I'm back from the field, and I've got the Centera AgVault software running. I've went ahead and selected where my imagery was on the micro SD card that I've got an SD card reader right now. That re-expose, and that was snapshot section number 15. So I'm going to go ahead and hit next here, and it's imported all of them. I'll go ahead and hit next, and it's going to bring in my images. Let's see. Looks like it's tiling together everything now, pulling it all in. You can see that the imagery for Centera did not have that area completed. I'm going to go ahead and hit next again. Give it a new field name. Yes, we're going to call that Adams Ricky. So I'll do this and I'll get back. You can see by the edit field information, so I've called it Adams Ricky based on the park. It's already filled in an address in a city in Pennsylvania and a zip code from the geotagged images. There's no grower or farm here, and there's no external field that I'm going to do. So I'm going to go ahead and save that and move on. Now, I've also imported all these same 20 images into Pix4D. These are the near infrared sensor images, and I'm going to go ahead and process those as well. The Centera software, if I switch over, did not mosaic this. It's a quick mosaic, and clearly it hasn't done any edge matching or linking of features. So I'm in the process of syncing this, and it's done on the cloud. which is why you need a subscription for this particular software. Apparently I can do the same thing in Pix4D, so let's take a look at that once we get the same 20 images brought into Pix4D. It is currently processing those as multispectral images, and it's going to take quite a bit of time, I think, but we're only just now in from the field, and we'll see how much time this takes. Last time I ran about this many images, it took about 20 minutes to fully process. The near-infrared images from Centera appear to have come in nicely, and they show what I would expect to see. Bright red for not very active vegetation, going toward the orange, yellow, light green, and eventually dark green. The images themselves look fine, but when you go to the entire field view and try to look at the quick tile NDVI, apparently it had trouble lining them up properly. So it was either an issue with the capture software and the order in which they were taken and rotations and all that, or there's something else still being processed on the cloud that I don't have access to yet. So we'll see where that goes. So clearly some stuff to work out there. The Pix4D software is still processing. I've got a very generic point cloud started, but it's still working through the images. So I'll see what we get there. Pix4D has completed its processing, and we have a near-infrared imagery going here, indexed based on equal area distribution of the values. Clearly the parking lots and lines even show up differently in the infrared results. I have not run any NDVI yet on this data. I still look into whether that's even possible over in the output from Pix4D. But nicely lined up, created this index. I've got 7 classes of reflectivity in the different areas of the bands, and going to work on exporting that to, as it says, you can export it to a GeoTIFF, which is nice. We can bring that right into ArcMap and overlay with the rest of our data. Another troubling piece of this, again, the near-infrared was captured through the AgVault field or aerial survey software, and the entire right corner, interestingly, of my images that supposedly were captured with AgVault did not show up. So over here in AgVault, one of the other troubling things is if I turn off the quick NDVI, the point features of where it actually took photos is nowhere near the orderly fashion that the mission planning software from Centera or AgVault did. So that's clearly an issue that we got to look into. The last thing I'm doing today is downloading the data from the actual Phantom 3 camera, and interestingly, the Centera AgVault software obviously it also captured the other RGB images at the same time. So on the main camera card, so you can see the overlap of the two planned images on here. So I'm wondering if I need to bring in all of the not only near-infrared but regular images and rerun them in Centera. Perhaps the other images help with the alignment or something. But right now I'm processing all of these images, quite a few duplicates in fact, in the Pix4D software. So I'll need to keep in mind in the future that I'm firing the camera, both cameras with the Centera software, and only the regular camera in the Pix4D capture software. So keeping those images separate after the flight and figuring out at what time I took them and all that's going to be critical. So I'll run all this again and keep playing around with it, but can't learn anything until you have data. So successful afternoon, and we'll continue to work at this process of drone mapping with both Pix4D and Centera AgVault for near-infrared. Hopefully everybody enjoyed this quick video. Not all the details are presented, but an overview of what we're working on so you can see the kind of work that's going on.